Hello again, guys. So in this video we are going to talk about function and recursion. So it will be a long video because it has a lot of things to explain, to be honest. So you're going to, well, in your first semester or something, you are going to create a lot of menus like printf, where you usually will put it in a while or do while. So let's make a do while. So let's say printf one at digit, and then to multiplication. Let's just create those two, and then 3 will be to exit this loop. Well, oh, I'm sorry, you're going to need to scanf. So we are going to create a variable menu and scanf %d ampersand menu. And then, well, menu is not equivalent to 3. Yes. So when you input 3, then it will get out of the loop. So you're going to use something like this a lot in your first semester, but you can, well, a function is basically line of codes that you can reuse every time without, well, without copy pasting all these codes. So copy pasting all these codes. So how you create a function is something like this. So there are 6 data type, I believe: integer, boolean, float, string, character, and the last is void. Well, void is only for function, so it will not return anything. When you are using like string, well, let's discuss it a little bit later. So void print menu. This is how you create a function, and well, you are basically doing this without the scanf. And let's keep it tidy. Okay, and then, well, you're basically only needs to call it. So print menu and scanf %d ampersand menu F11. I'm sorry. I need to give it backslash n, backslash n, backslash n. So this is the, well, the function of a function. This is what the function should do. So you do not need to copy pasting all these line of codes times 2 times. You can only just, well, if you want to print it a lot, well, you can just call it many times, right? Print menu, and then print menu again. So that is the core value of function. Oh, wait, I did not give it. Oh, so let's don't give it too well, because it will not stop, because I don't have any scanf. So let's check this. Well, this is the what function should do. So you can use the function many times. Just call the function. You do not need to. If you do not use function, then you will do something like this, and this will make your code very not beautiful to see. It is a lot of mess. So with function, you can reuse the codes and it will make it more tidier. It will make it tidier. So that is the brief of function. And now that is for void, and I will give you an example of integer function. So let's say, I'm sorry, let's don't. And then percentage D menu. I'm sorry, percentage D ampersand menu. And now let's get into switch case. Switch menu, case 1. So we are going to create a function of integer. So this will be add. I'm going to explain to you something called parameter. So let's first create integer add. So you can scan the variable here. So scanf to value, and let's give it integer a and b, and then ampersand a ampersand b. So a will be the first value and b will be the second value, and we want to pass this value from here, from integer main to integer add. So we are going to throw this value into here, and you can do that by 3 ways. Integer add ap, and then in here you call it, and you can use any variables, let's say y and z. So you're going to, with this example, you are going to pass the value of a and b and throw it into y and z. So let's say I input a with 5 and b with 10, then 5 and 10 will be thrown to this, to y and z. So y will be 5 and z will be 10. So you will call something like this, return. First, let me show you what the function first. So printf percentage d backslash n and y and z, and then we are going to return y plus c. Let's printf percentage d and ap. And then we call break after that. Let's try it. Is to break. So let's try it. What? So now we are going to input two values, 3 and 5. Sorry. Let's exit. Let's make it tidier. Printf percentage d backslash n. And then so as you can see, we are inputting 3 and 5, and from here, from A and B in this line of codes, we are going to pass a value. So when the value of A is 3 and B is 5, and 3 and 5 will be thrown into here. So Y will be 3 and Z will be 5. as you can see in this output, y is 3, 3 is 5, and then you can print the function with return. So I'm going to draw you. Let's exit it first, so I don't have any output. So well, a function is basically something like this. So you are going to have this block, and let's call it function at a b. And in this function, we are going to have a lot of codes, right? Like, let's just say that this is a code. And then you can like make this function into a variable. So a function is basically a variable, but it has codes before it prints a variable inside it. So how do you say it? So you can make this function into a variable by using return. So when the compiler reads this return, so like you return 5, the compiler will conclude that this, after doing all the tasks, will conclude that this function is a variable, and this function at AB is basically a variable of 5 when it reaches this line of code. So I don't know if you get it, but basically if you are using a return with a value, then the function will be a variable and it can be printed. So that is what I'm trying to say, I believe. And there is another thing you should know. There are 3 types of passing parameters. First is passing by value. So this is passing by value. You only use A and B. And let's say that you are changing Y in here into 10 and C here into 15. Let's create sum is Y plus Z, and it will return sum. And then let's try to printf percentage D, A is, and B is percentage T, A, B. So let's try 1, 3, and 5. Wait, and give it a \n, and let's try again. 1, 3, and 5. So as you can see, wait, let's not use it here. Let's use it here. So you guys understand, are going to understand what I'm talking about. 1 addition, and then we give it 2 values, 3 and 5. And so, as you can see, firstly, we are calling at A and B, which is at 3 and 5. So in here, in this line of code, Y is 3 and Z is 5. So sum is 3 plus 5, which is 8, and then we change the value of Y into 10 and Z into 15. So that's why in here, Y is 10 and Z is 15. And when the compiler is reaching the end of scope, this last bracket, then it will go directly into the next the next line of code. So from here, it will go to here. And we are printing A and B from here, which is 3 and 5. So if you are using only A and B, it is copying, it is passing by value. And whatever happens in here will not happen in here. So even though we change Y and Z to 10 and 15, in here, A and B is still 3 and 5. There are also another way to pass a parameter, which is passing by reference and passing by pointer. So I'll give you an example of passing by reference. Instead of doing this, we are going to add ampersand A and, wait, no, it is not. Instead of doing this, we are going to use ampersand Y and ampersand Z. And I believe this is done. Let's try 1, 3, and 5. So as you can see now, the value in here in integer add will be, the Y will be 10 and the Z will be 15. And now A and B in here is changed to into 10 and 15. So when you are passing by reference, both the value in the function and in the main function will be changed. So that's the difference. I don't know exactly why, but I believe it has connection with pointer. So instead of passing the value, you are passing the memory address, and that is why both of the value will be changed, both of the variables. Both of the value in those variable will be changed. And another way is using pointer. So, but the main function of passing by reference and passing by pointer is the same. We want to get both of the variables to change. So instead of doing this, we are going to use asterisk, and we are going to use the ampersand in here. I'm sorry, ampersand. So instead of doing this, we need to add the asterisk in all of them. So it is something like this, and printf asterisk 5, asterisk Z. Let's try 1, 3, and 5. So now it's the same as passing by reference. You are adding 3 and 5, and then so in here sum will be 8 because it is 3 plus 5, and then the value of pointer Y will be 10 and pointer Z will be 15. So because this is passing by pointer, these A and B will also change because Y and Z is pointing to the memory address of A and B. So that's why A and B in here is also changed into 10 and 15. I believe that is all for the function and passing by parameter. You can also try to learn it by yourself, but let's get into the difficult part of function, which is recursion. So recursion is basically a function that is calling itself. So let's try to create a function called factorial. So if you are like senior high school or above, you are going to know about factorial, which is basically written like this. So if you are 5 factorial, then it is 5 times 4 times 3 times 2 times 1, I believe. So let's try to create that. So with the knowledge that we have, let's try to create integer number. and scan that number, and then we call a factorial of number. And we will create a function called factorial with integer number as its parameter. I'm using passing by value because I don't need to change anything, to be honest. So let's say we are inputting 5, then the value of 5 will be passed into this number. So we will need to create a breaker, I believe. So the function will not loop forever. So if number is equal to 1, then we are going to return 1. Else, we are going to return number times factorial with number minus 1. So let's try. I hope it succeeds. Let's call it 5. I hope it will not loop forever. I'm sorry, I need to print. Printf %t and factorial number. Let's try again. 5, and it will result in 150, which is from 5 times 4 times 3 times 2 times 1. Let's give it another try with 10. I hope it will not explode, which is this. So that is for recursion. So I want to tell you that recursion has its advantage and disadvantages. So the advantage is that, well, recursive basically can do anything loops can do. So if you want to, well, seem as a very smart person, then try to use recursion instead of loops. So the disadvantages of recursion is that it uses a lot of from. And if you are not giving it a breaker, like something like this, then it will go loop forever, which will totally destroy your CPU. So I'm going to explain this. So let's create another. So recursion is something like this. So at first we are calling factorial of 5, right? And in factorial of 5, we are going to check if the number is 1. No, then you are going to go into this else part. So it will return number, which is 5, and you will times it with another factorial. So you're going to times it with another function. And now it will be factorial of 4. So factorial of 4. Because you are throwing a factorial of number minus 1. So it is factorial 4, and factorial 4 will be 4 times factorial of 3. Factorial of 3. And this is 3 times factorial of 2. And this will be 2 times factorial of 1. And when it reaches this 1, factorial of 1, then it will check factorial integer 1. If number is equivalent to 1, then it will return 1. So you can say that this factorial 1 will be concluded as a variable, which is 1. So now this will be 2 times 1, because factorial 1 is basically now a variable that value is 1. And now factorial 2 is basically return number times 1. So because factorial 1 is 1, then it is 2 times 1. So it will be resulting in 2. And you will return 2 in here. So 3 times 2, which is 6. And factorial 3 will be returning 6. And this will be resulting in 24. So factorial 4 will be returning 24. And factorial 5 will be resulting 120. And that's how it works. So that's how recursion works. And that is why you are printing 120. So I believe that is all for function and recursion. Thank you. Oh yeah, by the way guys, this is the end of the playlist because I believe I've taught you all about algorithms and programming. In the future, maybe I will create a playlist about data structure, which is very absurd. But let's see whether I will make it or not.